So those who have not got the license and the software download link, we will be provide you. You can email us, or you can send your message on WhatsApp, so that we can provide you the link. Those who have not got the download link and not installed.
So
If
can
there
you
is
start
any,
in 5? So can you start in 5 to 10 minutes?
sorry, what did you say?
So will you be starting in 10 minutes or now?
Yeah, I'm going to start within 2 minutes.
Okay.
Because people are joining, so I want that everybody should join it, and then I'm going to start it within 2 minutes. Yes, sure, I will give the introduction, everything. Just 2 days, the dedicated program is organized for all the participants, so that you will get benefited about our product, about the services, and how we can help you to achieve your goal in the field of research. Okay, we have very different innovative products, we have different equipment, we have software for simulation purpose. So it is not only a educated program, only a information. You will get many lot of things in this. If you will attend this whole 2 days training, then you will get to know many different things, including the simulation tool and some presentation about experimental equipment that will also be delivered after this my presentations. So let us start the session. People will continue to join it. So I'm going to start my session.
Hello. Hello, this is Dr. Jyoti Narayan from Northeast University. Good morning to everybody. I have already written the message to you yesterday, and that I could not download it. Actually, I tried for the last 2 days continuously on different devices also, but I could not download it. I'm very sorry.
So no issue. Those who have some problems, maybe some internal problem in your computer or network, but my team is there. My team can also help you. You can share your AnyDesk ID of your computer, TeamViewer ID or something like, so that my team can get access of your computer, and from my team, someone will definitely get help you. So you can type your message, or after this first half, you can write to me as well, and we can help you to do the installations. So those who have some problem, don't worry, we will help you. Let it concentrate on the presentation session that which is going to start right now. Then those who have problem, then we will definitely help you.
Okay, thank you so much.
So very good morning to all of you. Once again, welcome to all. Thank you for joining this session. It's good to know that good participants are there. Myself, Anil Sharma. I'm from Impulse Technology. So basically, this Impulse Technology is an Indian company. We are located in Delhi, Gurgaon, near to Delhi. And today we will discuss about this nano academic technology. That is basically a Canadian company. This Canadian company developed the software for atomistics kind of density functional theory calculation and this quantum technology simulations tools. So this 2 days whole session, first session, you will get to know about the presentation, that what type of features software exists. And then in the second session, the license is already installed in many of the computers of the participants. You can also make a practice in your computer so that you will have completely the familiar with the capability of the tool and how this tool can benefit it in your research. So let's continue the session, this presentation slides. If I continue about my parent company, my parent company's name is called Nano Academic Technology. This Nano Academic Technology is located in McGill University, Canada. So initially, they are from Montreal, Quebec, Canada. Spin-off from McGill University. They are developing the algorithm from 2008 by Dr. Hongo, Dr. Zhu, Dr. Lee. These are the 10 men, the founder who developed this Nano Academic Technology. They developed the software initially for quantum transports calculations, material development with more than 10-12 years of development, and including the quantum revolutions. They are developing the software for spin qubit semiconductor devices for qubit simulation along with the atomistics DFT calculations. A very broad range of product they are developing, and we Impulse Technology will help you to provide all the technical services related to this particular company. Many more companies are also there. I will introduce after end of this slides, end of this PPT. Now, in today's the session, what you will get to know, basically first session, I will show you a small presentation, what the software is, how the software capabilities are there, and how the software can benefit it. Then you can also do the hands-on training. 2 months license validity is given so that it's good enough where you can make practice. You can try to create different material. People may have different topics, different research field. You can explore, you can create your own project as well. So this software, there are 2 modules in our software. One is called Rescu and second one is called Nanodcal. Rescu is basically for material simulation only material simulations. And this Nanodcal is for material plus device simulation. That is NEGF package. So if you want to work on only atomistics kind of DFT calculations only, no device calculation, no electrode is there, no transistor, only material at atomic level, at crystal structure, molecular structure, density functional theory with the hybrid calculations. Then only Rescu is the code, Rescu is the module which can work on material applications. And the second module, Nanodcal, that is called device calculation, material as well as devices with the quantum transports device applications. So designing, modeling of material and device simulation, the main total agenda is today's demos. If I talk about the basic features about the software, that is called Nanodcal. Nanodcal is basically a state-of-art NEGF plus DFT code. Non-equilibrium green function plus density functional theory. DFT plus NEGF calculator is there. So it is written in MATLAB and C with many of the publications are there. If you will Google Scholar it, you will type Nanodcal on Google Scholar. You will find a lot of papers are there by using this Nanodcal softwares. It can simulate the materials. It can simulate the 2-port devices, bulk material, and device transistors applications. It majorly focus on IB characteristics, transistors calculations, mainly on the device part. Little bit about material as well. Material and device, both applications can be done. So either you want to calculate the electronic property, material device property, or transistors properties. Everything will be there. DOS, PDOS, LDOS, PLDOS, IB characteristics, thermoelectric current, IDVD characteristics, 2-port device, and molecular device application can be modeled in the software. And also you can do the simulation and visualization of your output. Everything can be done in single platform. If we talk about the material specific only, many people work on device application where they can define some electrode, some biasing apply on it, and transistors they can simulate. Many people work on DFT with the DFT perturbation theory calculation. So this rescue is also one of the code. There are two packages. One is rescue, another one is Nanodcal. Both can also be combined together. So this rescue is real space electronic structure calculator. Nanodcal is nano DFT calculator plus device simulations. This is based on DFT and density functional perturbation theory. There are two methods. One is density function theory, second one is perturbation theory. It will help you to optimize your structures based on DFT calculations, code from DFT package. Parallel implementation is also there for multiple core calculation. Response function, phonon band structures, optical property, Raman property, dielectric property, permittivity, refractive index, Bennier function, band unfolding, DOS, PDOS, LDOS, hybrid exchange correlation functions, susceptibility, charge analysis for at all material level applications. Then this rescue code will be very helpful. It can simulate large number of materials structures. So I have shown you two small slides. One is called Nanodcal, that is device simulation, and rescue is for material simulations. So this is main particular research field where either you want to simulate the molecular structures or you want to simulate the molecular based device application. You want to simulate the crystal structure. Then you can create a surface with different plane Miller indices. Different plane will be there. Complete detail you will get to know in this two days training. In presentation, only the basic overview. That's why the license is provided, and you have completely the small guidance that how you can follow up the our technical expert so that you can also create different structure in your particular systems. So surface structure with different planes. 100 plane by defining the Miller indices HKL value, the 100 plane, 001 plane, whatever the plane you want to simulate your bulk material crystal, you can simulate it. Also, the complex material is there. If you want to define some different lattice parameter, you can define some lattice parameter, alpha, beta, gamma, ABC value, some lattice hexagonal, tetragonal, monoclinic, diclinic, triclinic. That kind of structure can be created, including the heterostructures, interface between two material. Let's suppose some two semiconducting material. You want to create the interface. So interface between two material or three different material, four different material, five different material. Multiple combinations will be there. You can create the interface structures. Different complex material library are there. You can create a molecular complex structure. You can introduce some defecting, some N-type or P-type dopant you can introduce also to create the defect. You can rotate, delete, add the atom. Very different type of manipulation will be there. The software user interface is there, which will help you to create your structure quickly instead of writing the script or writing the code. Learning the script is complex task. That's why the user interface, which you can visualize, device studio. The device studio, which already have installed in many of the computers, that is called user interface. I introduced about Nanodcal Rescu. That is main calculation engine, which will solve the perturbation theory, which will solve the non-equilibrium green functions. And that will calculate your electronic property, IV characteristics, and transistor characteristics. So mainly, there are three parts in the software. One is called the pre-processing modeling part, where user can import their material, user can customize their material parameters. How it can be done, that we will educate in the training program after this presentation. So there are three parts in the software. One is called pre-processing, where you can model your structure. Whatever type of you want to create the structure in the user interface, it is simply a plug and play. where people can create it quickly. Maybe complex task, but user interface is there so that you can build your structure quickly. And then setup calculator is there where you can select particular features of theoretical parameters. Let's suppose you can select the basis sets, you can select the electron temperature, you can select the K-point sampling, some iteration control parameter, iteration sampling point, spin related effects, and some pseudo potentials. These all things can be set up from the user friendly DFT calculator. And then simulation is there. You can also run the calculation and visualize your output. It is all integrated software where you can also visualize your results in our interface. You can calculate the electronic property, structural property, optical property, thermal property, magnetic, electronic, thermal transport, electron phonon coupling. These all property can be calculated, including some device as well. I will show you what kind of property inside in these. Okay. So IV characteristics and many more things will be there. You can also check in your computer. Now it will not focus on only nanotechnology, nano device, including if you want to see spin effect, material, spin movement of the spin orbit interaction. That will be possible to lower power application, high power density analysis, spin polarized application, nano application, nanowire, nanotube, molecular structures. You can check spin related effect, electromagnetic effect, Lloyd, electron phone is possible. The tool. Spintronic devices. Let's suppose you want to see monolayer structures. You can play structure, you can buckle, zigzag, armature, zigzag kind of nanoribbon. You can movements and some magnetic property, magnetic atom texture properties, some spin up and down calculation.
Sir, your voice does not clear, sir. Something is wrong.
Sir, your voice is not clear. Voice is breaking.
My voice is getting low. Yes, sir. Hello.
Sir, your voice is not clear.
Sir, even the slide is not moving. Just a minute, 1 minute. Am I audible now?
Yes.
Yes, sir. Okay, yes, sir. So perfect. Let me continue the session. So only the participants should keep patience. If something problem is there, kindly you can interrupt me.
Sir, can you continue the previous slide because from last 2 minutes we did not understand anything.
Okay. So if you want to understand from this slide.
Yeah, sir. Please start from
Yes,
this
sir.
slide.
Yes, sir.
Okay.
Yes, sir.
So basically, you can the software is dedicatedly designed, developed for material application and device applications. If you want to simulate the molecular structure, we have a molecular builder is there, which you can also visualize in your computer. The license is given. You can build your own molecular structure, or you can import your molecule. You can create your molecular based device applications. You can create the surface structure where you can define some Miller indices. You can create the plane different 100 plane, 111 plane, or any plane you can create. You can create a complex structure by defining the lattice parameter, some alpha, beta, gamma, ABC value, or rhombohedral,
request you all
hexagonal,
to join.
tetragonal.
And it's open for you all. You can join the PR team, the social media team, the technical team as per
Participant,
your
kindly unmute
choice.
your mic.
Now, this was about the event. Now, I'll also tell you about the mentor-mentee system here.
Sir, you are not audible.
Your microphone is muted.
Hello, am I audible?
Yes, sir.
Okay, sorry for that. So basically, you can create the complex material interface between two different material, three material interface heterostructure, complex carbon material waste structure. You can create. There are three things in the software. One is called the
Your slide
pre-process.
is not.
So your slide is not visible.
1 minute.
So meanwhile, I want to ask the cited example. Has they used this software, or is it just citation from literature?
Sorry, what did you say?
Sir, the citation which you have mentioned on the slide, has they used this software or this?
Yes, definitely they have used our software. We will show you everything, whatever question in your mind related to papers, related to features, related to everything. Just to you have to listen these things. Many of the doubt will be cleared. So I want to
Sure, sir. Thank
continue
you.
the session.
Yes, sure, sir.
Now here there are three things in the software. One is called advanced building tool, where you can create your structures, you can model your structure, you can manipulate your structures. Maybe you have different type of structure, because many people working on different applications. We have a completely user interface software where you can customize the structures. You can manipulate, you can introduce different defect, you can add, delete different atoms, you can supercell, create the structures. So manipulation will be done. How it will be done, that's why you have to wait for 2 days to learn everything. Still, the 2 months license is given, where you can also explore by yourself according to your particular research topics. We have not only a modeling part, user interface, we have a user interface setup calculator, where you can select particular feature, some DFT parameter, some k-point sampling, basis sets, exchange correlation functions, and some pseudo potentials, spin type, and output visualization is there. And still the software is also integrated with MATLAB. So MATLAB integration is also there. Many files you can visualize in your MATLAB tool. You can plot electronic property, structural property, optical property, thermal, magnetic, electronic, thermal transport, electron-phonon coupling. Apart from that, device property, IV calculation, thermoelectric current, C-wave coefficient, that can also be plotted. If we go for Spintronics application, some people work on Spintronic device. So basically, since the software cover up many applications, so you can work on next generation Spintronics device application for lower power consumption, higher power density to increase the performance. You can introduce the spin orbit coupling, spin up, spin down, spin up band gap, spin down band gap, electron phonon interactions, photocurrent light falls, magnetic property, atomic magnetic textures, that things will also be there. If you want to simulate the single layer structure, monolayer structure, bilayer, trilayer, buckling you want to create in your structure, buckling can be created like this is single layer graphene layer, yellow color, top side boron and nitride and bottom side boron nitride. You can define that kind of flat layer, then you can introduce some defect in the sheet and you can create some properties. You can find the direct material calculations, direct band gap, indirect band gap, PK diagram with zigzag, armchair, zigzag, buckling, and some rotate type of defect can be created. In the presentation, general overview about the tool will be there, but coming training will be shown to you where you can use the software capabilities. Those who work on molecular related application, the molecular structure can be simulated, molecular based two-port device can be simulated, and transistors can also be simulated. This is one of the graphene molecular layer in green layer molecular is there. Left and right side anode and cathode electrode is there, and this is central gate region is there. So if you see in graph A and B, two different molecular structure in center of the region, and two different electrode are connected. Two different electrode is connected.
Sir, your slide is not visible.
Slide is visible.
Sir,
Molecular
your slide is
electronics
not visible.
not visible.
Yes.
Sir, it's visible.
Okay. So this molecular electronics, we have two different molecules there. Accordingly, the transmission spectrum is calculated with respect to energy. So material level, device level, and transistor level. Up to 6 probe device can be simulated with the software. So this is complete a first principle ab initio DFT calculation softwares. So first principle for electron transport calculation for 2 terminal, 3 terminal, 4 terminal, or 6 terminal devices. Let's suppose you want to see here. This is one of the vertical layer, horizontal layer. Two different materials are there. You can define the top electrode, left electrode, right electrode, bottom electrode, front and back electrodes. You can rotate particular nanotube sheet. You can plot it, the characteristics. This is one of the 6 probe device structure. Molecular is connected in between. And you can plot the material band structure, then device conductance and device related properties. Apart from electronic structure or electrical characteristics, thermoelectric magnetic property can also be calculated. So thermoelectric for power consumption, power generation or cooling, the efficiency of the material to transform heat into the electricity. So that's why the thermoelectric calculation is also there to convert temperature on different temperature. You can calculate under different electric field, figure of merits. If you see, this is one of the nanoribbon. Graphene graphene layer structure is there. Thermal conductivity, electronic on different temperature, 50 Kelvin, 100 Kelvin, 150 Kelvin. So different temperature, the thermal conductivity is calculated. ZT you can also calculate. You can calculate the conductance, CV coefficients, ionic thermal conductivity, electronic thermal conductivity, DC and AC conductance, ZT, CV coefficient, band and folding, DOS, PDOS, LDOS, band structure, complex band structure, many more things will be there, including IV and photocurrents. If someone want to work on photodetector, the photodetectors is also possible, where you can work on that. You can apply some different light, spin orbit interaction, non-collinear spin, electron phonon interaction, polarization. You can define the energy range. Like this is one of the coordinate points. You can take single layer, double layer, define the source, drain, gate, and photons you can fall, and accordingly you can calculate the photocurrents. So armchair, zigzag, whatever type, the software is already provided to you. If I introduce about different product and services, not only a nano academic product, we have a product for solar cells, tandem, thin film, and other applications. These are our multiple products that we are providing. If you see here, I have introduced about Nanodcal and Rescu. Their plus version in Python is also in development for latest technology, including the quantum technology tool. If you talk about top company, that is called Fluxim SatForce. This is basically a simulation software for perovskite, tandem, thin film, organic, solar cell and LED, including quantum dot. So those who work on micro level application, photovoltaic application, optoelectronic device applications at micro level, then SatForce one-dimensional, Laos two-dimensional losses simulations softwares. We have a more coming webinar on this SatForce and Laos in this end of this, I guess something probably. So this other product, whatever you can see, we will shortly organize the training program as well. We have an electrical optical characterization, spectrometer, source measuring unit, stability analysis product, degradation analysis product, ELPL measurement. So SatForce is solar cell one-dimensional, Laos is for two-dimensional, PIOS is for electrical optical characterization with one click of your sample. For ELPL, electroluminance, photoluminance, OLED measurement, Philos is there. Degradation analysis, Litos is there. Stability of perovskite, this Litos light is there. So for micro level optoelectronic device simulation, the top company product is there. For DFT atomistics kind of simulation software, we have this bottom of the company page, Nanodcal Rescu, and Quantum TCAD for quantum spin qubit semiconductor device. These are all commercial software. We have given you the trial version to explore its capabilities. So this is all about few of the product information. If you talk about other product, if someone want to work on experimental, we provide the probe stations, micro probe station, where you can also characterize your samples. So this is one of the probe station, stainless steel made, tungsten probes can be connected, vacuum compatible chamber on different temperatures, vacuum and gas compatible chamber. You can create the chamber, different sample can be placed. It is customized probe station. Inert gas will be there, temperature controller, pressure controller, humidity controller is there, and you can characterize your sample by using this probe station. We can also place this LED, the source. This LED lamp light can also be followed on that, and even sample holder will be there, which you can place sample on your sample holder, and that can measure the 6 pixel at a time. So shortly, after half an hour, we will give you the presentation about this product. So this is all about the product range that we are basically our company is promoting in India. Some probe station product, we will shortly have a demonstration by our another speaker. But before that, I want to show you the user interface, the software, how you can model the structure. You can also drop an email on this email ID, or you can already have the WhatsApp group where you can type your message, whatever problem you have. You can type your message, we can help you, those who have some problem related to our product. So thank you for listening the presentation session only. Now let's go to the demonstration. So software may be installed in your Windows C drive, and then device studio folder will be there. And there is a bin folder inside the device studio. So you can find there is a one xzwtech.lic file. This is one of the license file which will activate your license. This license should be available inside the bin folder. Then only your license will be activated. Once it is there, then you will find the device studio application file. This is the application file. So I would like to double click to open this software interface. You will find initially this interface. Here you can find there is welcome to device studio. Use the control below to create a new project or open existing projects. Since everybody is starting from scratch, so instead of opening the existing project, you can create a new project. So create a new project and click on OK button. And this is the name of project. Since we are going to start from scratch, so we can save where you want to save your project name. So this is one training as an example. Name of the file I am giving as a training. This is hands-on training. That's why the file name is training I am giving here. I click on save. Now the empty project with the name of training is created. I have maximized the screen. Now you can see this is our user interface. This user interface will help you to model your structures, to manipulate your structure, to create whatever kind of material you want to import or you want to design. Now, if you see there is a file option is there. First of all, you can click on the file option and you can find import button. There are two options are provided in the import. Import local, import online. Local in the sense, when you install the software in your computer, there is one local library of the material are created. Local means your computer. In your computer, there are some database of materials are installed during the installation of the softwares. That is the meaning of import local. So when I click on import local, since the software is installed in my C drive, device studio, material folder, and these are different materials folder are there. If you will locate the material, you will find lot of material are present. Either you can find zero-dimensional material, amorphous material, crystalline material. This is the library. Library of the material are installed by default when you install the software. HZW is the unique format of this particular product. If you will go for another particular folder in one-dimensional, you can find one-dimensional carbon nanotube with different chiral vector. That's why 5 by 5, 6 by 6, 7 by 0, N and M. N and M, that is called chiral vector based carbon nanotube material file are there. If you will click on this two-dimensional, you can find some nobility material, arsenide, bismuth, black phosphorus, hexagonal boron nitride, and some graphene material are present. This is the default material library where some conductor material are there, insulator material are there, layer material, magnetic material, oxide material, metal oxide, some nobility material, semiconducting materials. Whatever material you want to work, that particular folder, you can locate it and you can select the material which you are working on it. You can find these are different materials given in default library. In HZW is a unique format of this particular company. But if you have some different extensions, let's suppose you have a XYZ format material file. Then you can see here, these are different other extensions which can directly upload in the software. If you have a XYZ file, if you have a CIF file, CIF crystallography information file, XSD file, postcar file, quantcar file, scf.input file, relax.json file, aimd.json file, .as, .mol, .pdb. These format file, you already have your material, you can directly upload in the software. If it is not there, then you can search in our library. As an example, let me take silicon material and click on open. Once you click on open and then click on maximize this screen. This is our user interface. This interface will help you a lot to model your structure quickly. So here you have no need to write the code. I have simply imported the material from our existing database. What I did from the beginning, I click on file option and I click on import option and import local options. From local, my own database, I imported the material. These are different library are there. Whatever material you will locate, you will find a lot of materials are given default. This is one of the procedure where you can import.
Hello?
The,
Hello?
Yes.
Sir, can you please tell us how to draw the new material from the scratch as
Kindly
you
wait
told?
it. I'm explaining everything, so kindly wait it. I will cover up slowly. That's why the training program is 2 days. You have to keep wait. I will go to all the steps, whatever in your mind. And still after that, some query will be there. I will be happy to discuss on your questions as well.
Okay,
So
thank you.
Yeah, please wait. This is one of the procedure which I have imported from my local material. The second option, if the material is not present in library, let's suppose is not default given in that, then you can click on import online. This is second method where you can, if the material is not present, you can search the material in our online database. It will fetch the material from open source library by simply mention the formula. I mentioned the formula of, as an example, MOS2. Whatever material you may be working, you can mention that formula and click on search button. Once you click on that search button, you can see the combination related to MOS2 is generated. These are all ABC, A equal to 3 point something, B equal to 3 point something, and C equal to 3.98 something. Alpha equal to 90, beta equal to 90, and gamma equal to 119. So this is a cell length, lattice parameter ABC, alpha, beta, gamma. If you scroll down, you can find the coordinate point of molybdenum and sulfur atoms. So molybdenum and sulfur atom coordinate points are there. And once you click on this add button, there is an add button nearby that. Once you click on it, the atom will be, that particular material will be added. So this is one of the procedure. I have imported the silicon from my local database. Second option, this MO2S4, which I have imported from my online database. This is two method. Third option is called where you can import your own material. Let's suppose you have a CIF file. You are working on any other software and you have material file. And that material file you directly want to upload in our device studio instead of create from scratch. So you can create an import local and then you can find the path, the location where your file is present. Let's suppose if you see here, this is one of my CIF file. In this CIF available. If you already have, you can also select that particular location and click on import, open. It will open that particular material by this particular procedures. So this is 3 procedure where your own material in different extension that can be uploaded from local library can be uploaded, or from online you can also search it. And now the method is called create the new material. You don't have any material information. Don't have any material file. You don't want to upload from database or online search. You have the latest informations. You know the ABC value. You know the alpha, beta, gamma value. You know the atom and their coordinate points. Then this is the next step. You can create a new device from scratch directly. You can create a new crystal. You can create the new molecules. If you want to create a crystal, you can click on new crystals. This is a crystal builder where you can build your crystal from here. So sometimes it is difficult to jump on your queries directly. I will go to particular flow so that you will have some whatever your query may be there, maybe some automatically be resolved. Still, if will be there, then I will be happy to provide you the solution after this training as well. Now here you can see the space group. You can see this is different space group of the lattice. 1p1, 2p1, 3p2, 4p21, 5c2, 6pm, 7pc. You can scroll down. Once you scroll down, accordingly the bravest lattice, orthorhombic type, the space group, whatever it is selected. So simple cubic, hexagonal, bodycental, FCC, rhombohedral, tetragonal, triclinic, whatever type it is there. The bravest lattice, you have to select the space group, and alpha ABC value will be automatically enabled, the particular checkbox. This will automatically enable it. You can see here the B value is hidden. Why it is hidden? Because hexagonal, this B value is not applicable. That's why you cannot mention, you cannot change the value of B. Only A and B value can be changed. Similarly, the CYA, you can define it. So whatever parameter will be there, that will automatically hide or delete. If you click on this plus button will add, you can select the sodium here and click OK. That will replace it. If you will again select particular different position, you can add another element. You can add that number of element, and here you can change. Let's suppose you want to create this NaCl. I want to change it. It can be changed. And click on preview. It will create the type of structure, whatever you want to create. It can be created from here. So by defining the accurate value of your input coordinate points, you can define here the value of lattice parameter. Preview, then you can visualize it. The information of selected material. The information of selected material will be here. So ABC, vector alphabet, this vector A, vector C, total number of atom in this unit cell, it is displaying here, and chemical formula of this particular unit cell is displaying. We have a lot of combinations to create different structures. Now, we will go slowly because I can not directly create the complex structure. We have a different workflow for that we will follow it. Let's suppose as an example, you want to simulate this simple material without doing any manipulations. So you can go to the simulator and go to the Nanodcal and click on SCF calculations, self-consistent field calculations. So this is SCF calculations. Once you click on SCF, is basically a self-consistent field for DFT parameters, where you can see the electron temperature, default value is there. You can define whatever the value. For advanced exchange correlation functions, hybrid and